We can start with our first problem. This valid palindrome. So it's like they have given a non-empty string s, and we may delete at most one character. So judge whether we can make it a palindrome or not. Let's say here ABA. Here at most one character means either 0 character or 1 character. So here we are deleting 0 character, and because ABA itself is a palindrome. And if we look here, C, if you delete, then again ABA is a palindrome. And here the string will only contain lower letters from A to Z, and the maximum length of the string is 50K. Yeah, so any queries in the question?
So maximum there will be a difference of only one character, right?
Yeah, exactly.
So it looks very normal, like the valid palindrome. Only we just have to consider if any character which is not actually matching.
Yeah.
Just try to delete a character and then see if it's a palindrome, right? Something like that. A very high level
Yeah.
brute force way. So go through the string, and each and every time just delete a character and see if it's a palindrome, and the rest of the string is palindrome. Keep on doing it, and if you find any time it's a valid palindrome, then return true.
And we have to take character of deleting also, right? Should not be more than 1.
Yeah, so always delete one character, and again when you go back to the string, put that back in if it's not valid.
Okay. I thought that we'll delete some characters and then finally we'll check. So after every step you'll be checking by deleting one character.
Right. You delete a character and then check if it's a palindrome, the rest of the string, and again put that character back if it's not a valid palindrome. So do to the end. So that will be a very brute force way. I think it will be almost like an n square solution, right?
And yeah, for check. Should be n square.
I think so. It will be n square, right? So because every time we will be going through the loop, okay. So and also for every character we are going through the whole list, no? So it will be n square.
Means when putting back the character, if by deleting it we are not aware.
Yeah, see, in Java, you'll have to delete a character specifically, but in C sharp, sorry, it's not C sharp. In C++, what you can do is you can actually mark an index saying, okay, I don't want this character to be taken care of when you're actually considering the valid palindrome function. Just ignore that character at that index and just go ahead. So you don't even have to delete it if it's a C++. So there might be a bit of optimization, you can do it, but still the solution is O(n) square.
Yeah, it will be.
Another approach.
Go ahead.
Sorry. So there is another approach I was reading through, and I have done it that way. We can start from both the ends. So if it were a complete palindrome, then if we start pointers from both the ends, then the character there should match. So A should match, the first A should match with the last A, and then the pointers will be adjusted. I mean, the pointer at the start will be incremented, pointer at the end will be decremented, and B will be B. And then once we have crossed it, then it will be over. I mean, so that is the simple palindrome check, right? Here the twist is there is only one character which we might need to ignore. So in the example 2, the only one character is either we can ignore B or we can ignore C. But in the approach that I was saying, we'll start with the first A and the last A. They match, so there is no problem. we'll continue shrinking the pointers. So the first pointer will point to B, second pointer will point to C. Now we know that they don't match. So only one exception we'll have to do, only one time. We will either ignore a character on the left pointer or under the right pointer, and we'll continue.
Yeah, that's interesting.
So that way, so now, yeah, so that is what people are doing, and I have done that way.
Okay.
Yeah, I have done it similar too, like you.
Okay, Rajendra, you want to share that or?
Sure, sure. Can you guys see my screen?
Yes. Yeah.
This is a recursive one. So there is a global one. So, okay, there should be only one time excuse. Only one character should be excused. Okay, so I'll come to that. But each palindrome is just a simple palindrome. We will go till the, so we have two indexes, starting index, end index. The first one starting from 0, second one starting from end minus 1, length minus 1. If the, so these are the limiting conditions. Just religiously I put some limit conditions so that the recursive function doesn't go on. So if
And it's a good optimization, like only up to half the length you are checking rather than checking the full length.
yes,
I mean, if it is a palindrome, it's good to check only up to half, right?
correct.
Yeah.
Correct. Still, I have got, if there is any loop, any problem in my code, then if they tend to, pass each other, so the beginning index, if it passes the end index, that means we have already switched in this case.
Cross.
Okay.
Crossed. So then we have already found it is a palindrome already. So this is nothing new, right? This is just a normal palindrome definition. Now, suppose the very first time, so we started with 0. I mean, the beginning index was at, index was at beginning and end index was at the end, and the values, the characters are the same. Then the problem now becomes finding out the remaining, shrink the pointers and try to find out if the remaining string is a palindrome. Okay. Now, here is the interesting thing. If they are not true, if they're not same, that means we have got to the situation where we'll have to ignore exactly one character. So that is where I'm saying, have I already executed this code? This is the code. Okay. Have I already excused any character before? If it is so, then it is the second time I have been asked to excuse. Then this is false. There is no, no such palindrome possible with this restriction. Otherwise, I am recording that I am excusing the each palindrome method once. Now, I will basically skip either from the beginning, where in the case of A, B, C, A, I'm basically saying ignore B and move on. Okay. Or I will ignore the C and move on and continue. Okay. Only one time.
Okay. So you'll take either B or you'll take C.
Yes, correct.
Okay.
So, and now that I have said I have already given one excuse, I will not give it again. That's all.
Yeah, makes sense.
Yeah. I just from language perspective, I wanted to, why this const variable you are taking constant?
This one?
Yeah.
That is just this is just a, so just like C in JavaScript, function is also a value. It is just a function pointer which you cannot change.
Oh,
Yes.
that's a constant. Okay.
Okay. Okay. No, I was learning. Slowly JavaScript. So.
Okay.
Yeah.
I'm also learning Python. I'm thinking of learning
Really?
Python.
So I should also learn Python then.
Yeah.
Actually, in JavaScript, there is a way like when you are declaring a function or let's say an object, everything is an object, so you can store that in a reference. Now,
Voices.
Hello.
I think you got busy
Okay.
somewhere. Okay. Yeah, let's continue.
Okay, I can stop sharing them.
Yeah. And what is just small like I have a lot of confusion between var and let.
Okay, so
Yeah.
let is a basically what should I say?
Local.
Let is local. Var is something called hoisting. So what happens is if you are declaring this thing here, then only you want this excused to be declared before it is used here, right?
Yeah.
In other programming languages, that is how it works. But in JavaScript, you can even write excused equal to false after you used it using var.
Okay.
So var, that is called hoisting. So it is kind of the language does two passes. So one pass, complete pass it does to find out how many vars are there, and then sort of it rewrites them in the top. Okay. And then and there is also scope bleeding happens with var, which doesn't let it happen. For example, if in this block there is this let, okay, if there is another parallel block, this let will not bleed through it, right? But var bleeds the variable through the scopes. I don't exactly remember all the details right now, but let is a very good substitute always. So I always go with let. Otherwise, var has got very bad surprises. One because of the hoisting, the other because of the scope bleeding.
Look. So if we declare let within if, we can't use in the next if, right?
yeah. So can I tell the difference exactly?
Yes.
If I'm audible. Yeah.
Yes.
So in JavaScript, what happens is whether you are inside, let's say you are inside a closure or you are inside a function. Okay. Then you can declare var. But when if JavaScript is not block scoped for variables which are declared using var. So if I say I have declared, let's say a var boolean, a var bool is equals to false, that resides inside if statement. So what will happen is as the sharer said that there is some term known as hoisting. So what will happen is because for variables JavaScript is not block scope, so it will push the variable declaration to the top, which are declared with var. So var will be available throughout the function. Okay. And what let state says, if you have declared a let variable, a variable defined by let inside an if statement, it will convert into a block scope because it is not a var but a let. So it won't bleed out of that if statement. So if you try to declare it again, then then there will be a problem. But in case of var, you can redeclare it. So that's the difference, one major difference. So it converts the variable declarations when you are using let to be block scoped in JavaScript. But that is not the case with var. Variables declared with var declarations are not block scoped. They are only scoped to the functions or to the closures they belong to.
What is the closure to, sir?
A closure is like, you can say that, let's say I am writing some piece of code in Java or in TypeScript where there is a concept of classes, right? So every data member that belongs to that class will be binded by the context of that class only. You understand my point?
Yeah.
Similar functions are there in Java because you cannot declare classes. I think you can in ECMAScript 6, but before that, what users, what developers intended to do when they needed to bind some variables inside a class or an object, they created closures. So what closures is, all of the variables that are declared inside the closure will remain inside that closure only. And let's say I have a function I have declared is using a closure, and there is a nested closure. So variables declared in outer closure will be accessed only by the inner closure. Similar to concepts like I have two classes. Let's say one class is A, another is B. Okay, and what I have done is, let's name it differently. I have a base class and I have a derived
Do you
class.
want to share your screen?
Actually, I'm on my mobile device right now, and
Okay.
I'm
Please
away
continue.
from laptop. Okay, yeah. So let's say I have a base class and I have a derived class. Okay. Now, what derived class does is it extends base class, but base class has two data members. Okay. Let's name them variable 1 and variable 2. Okay. These two variables resides in the base class. Now, when I extend it, these variables will also be accessible within the derived class. Okay, because you extended the base class. So when we convert this piece of code into JavaScript, so what it does is it creates a closure which points to the reference of the base class and declares two variables, variable 1 and variable 2, inside the outer scope. Okay, now all of the classes or all of the inner closures. So in JavaScript, what we say derived classes, how they create derived classes is by defining inner closures within other closures, within outer closures. So you can access any variable that belongs to the outer closure in the inner closure, but not the other way around. Okay. So if I would have got a screen, I could have explained it much better. But I'm sorry for that. I am right now on my mobile device.
Yeah, but it got cleared. Like, but there is no such concept class in JavaScript, right?
You can in ES6 there is, I guess. So I actively write my code on TypeScript because I am from a Java background, and when I tried to know how TypeScript compiles the classes into JavaScript code using TypeScript compiler, what it does is it converts every other class into a closure, and it is as simple as that.
Simple. Yeah, makes sense.
Wow, there's something different to understand and learn. Yeah, good.
Yeah,
Thank you.
exactly. Yeah. This language is picking a pace nowadays. I'm saying this JavaScript.
Yeah. So what people are more tends to do now is they are moving on to TypeScript because JavaScript has some silly things which a new programmer will always get trouble into, whether it is debugging the code or writing the code, because TypeScript is more oriented towards the classes or other OOPS concepts. It is better to use TypeScript when you want to use when you want to create scalable applications.
Good. Thank you.
The rules which are not followed in normal language are used in Java, are followed in JavaScript, right? I mean, on a higher level.
What you can try: open up the Chrome, open up the inspector, and declare a variable and assign an empty string to it. Okay. And on the other hand, declare another variable and assign 0 to it, and write a simple check whether your variable which was an empty string, double is equals to the variable which is number is equals to 0, and it will return true. And it will definitely return true. And you will be like, how the hell this happened that empty string is equivalent to 0? So in terms of false conditions, there are pretty much very silly checks implemented by JavaScript, like empty string is equivalent to 0. And there are much more checks like this. So it can get you into trouble while you write some code and you ignored that. So a lot of new programmers who are just programming JavaScript do a lot of these mistakes with the checks especially.
Exactly.
Yeah.
Thanks.
Thank you. Let's move on to your code session.
So what first I did, like original string, I reversed it. If both of them are same, then we return true from there itself. That means 0 deletion of characters. else what Rajendra was speaking, same, left to the first index and right to the last index. And as long as you find that left, your first character and the last character are same, just try to shrink the pointers. So this is what I'm shrinking the pointers. And in case if I find that there is a place where first and last are not same, so I'm leaving first time the right character and just this will slicing. I mean, it will take the string from left +1 to right +1 and just check if reverse of it is true, then we'll return true. Or the other is like I'm leaving a left character, and in the second case I'm leaving the right character. And here also I'm checking if by leaving that right character, if I can get the reverse string are same, then true. Otherwise, if all these cases are not valid, at last it will return false.
So this is the iterative way of doing it, right?
Exactly. Yeah. He did it in a recursive way.
Right.
Yeah. So this is like here I'm leaving my left character because left +1 I'm doing, and here I'm leaving the right character because I mean in Python it won't take the last one less than the last it takes. So this one, yeah, it's iterative.
What would be the complexity of this code?
Complexity, this while loop will go order of n. I mean, as long as you find, let's say if the entire string itself is a palindrome, then it will be order of n. It should be order of n only. Yeah.
Right. I think so.
But we are making two calls.
It's making several calls, but it is still order of n, right?
Passes will be more, but yeah.
Yeah. So for example, line number 3, it completely reverted the string. So that is order of n. That is 1.
And yeah. Yeah.
Then the line number 8, that is another order of n.
Again here.
Here also. Yeah. That's
Yeah, 4 passes will be there, but overall it will be order of n.
correct.
Because it will just go to only one condition.
Exactly. Now we can switch to next then. Now any queries?
Yeah.
Okay. So next is like removing the duplicates, sequel of previous, from sorted list 2. So sorted linked list is given, and we are supposed to delete all the nodes that have duplicate numbers, leaving only the distinct ones from the original, and just return the linked list sorted as well. Okay. So 3 will be wiped out and 4 will be wiped out. So 1, 2, and 5, and here 2 and 3. Yeah, that's it. So how do you approach?
So what they say is whenever you find a duplicate, you need to remove the duplicate as well as the original one, right?
Exactly. There is a confusion at times, like should I keep one and remove the duplicates? But here it's like they are wiping out the entire thing.
Yeah. So, but that is, if you just look at the problem statement, it doesn't actually make sense that way. But if you look at the example, then it actually,
according to the problem, it should have been 1, 2, 3, 4, 5, right?
Yeah.
But here explicitly, by looking at the example, I think we can ask from the interviewer for this. Or it's saying like delete all the nodes that have duplicate numbers, but still it's not.
A bit of confusion, yeah.
Yeah, exactly.
Yeah. So it will be a simple linked list problem. Just keep on deleting it and just delete everything, whatever you have. Duplicates, right? Yeah, but there will be some corner cases to handle.
Empty list or something like.
Yeah, empty list and the header. If it is, because if you are at the start, and then you'll have to take care of it, right? In the example 2, you have 1, 1, 1, which starts from the head. So if you have to delete the head also, again you'll have to manage the head pointer.
That is the trick. Like, how would you shift from 1 to 2?
Yeah.
So that this entire will be removed out.
I think, in that case, like, I think in one of the session we had this linked list session. So creating a dummy node would make it a more generic solution maybe.
What advantage it gives?
So when you create a dummy node, like you don't need to handle the corner cases. Like let's say in the second example, like like when you're starting from the starting node, the starting node itself is repeating, right? I mean, I did not.
Okay.
I see such kind of questions where if you have a dummy node, your whatever the while loop or the recursion, it becomes easy. You know, it doesn't need to handle any case. And
Exactly.
when you're returning it, you can just say like dummy dot next or dummy dot.
Yeah, that is like, I mean, apart from dummy, return the original head wherever it was. Yeah. You want to share code or something
I
like
did
that?
not solve it, but I mean, when I was looking at it, I felt like that it's one like we could use that. Thing.
Yeah, I think Naga had that session, right?
Yes, yeah.
Yeah.
I learned from that session. So.
Absolutely. Yeah, it makes the code very easy to read as well as implement. Yeah, that's true.
Yeah, if somebody wants to share code.
Actually,
Like,
even I tried
sorry, go.
without using the dummy node.
Okay.
So yeah, so the problem I was facing was so I was maintaining a pointer until which linked list was exactly without any duplicate. But without dummy node, it was really difficult for me with the example to where should I put my dummy node, where should I put my pointer until which the linked list was without duplicate, and it was really difficult for me to code it directly that way. Yeah, using dummy nodes, this makes it, yeah. So that's the problem I was facing without dummy node. But with that dummy node, it was easy to code. But I didn't code it, but I saw some discussions and it was easy with the dummy node.
Yeah,
that's true.
So I'll show you mine then.
Okay.
So this is like this is the dummy node that I've created with none as a data in it, and original list I've added to my this pseudo pointer. Like head was having a list here, and just keeping it in rather than moving the head, I've taken a variable node. As long as my node is not null, I'm checking if nodes next and next value both are same. Then I'm taking that value in another variable called duplicate and just incrementing the node by one more pointer. And so I took the duplicate node here. Now what I'll do, I'll keep on checking which all nodes are similar to this particular value. And as long as I find that no, this is similar to this, just keep on going, keep on going. The moment you hit that the duplicate value and the previous, they are not equal, just a slight, what do you say? Like to the previous one, just to make it none so that this will go away, 111, and you'll be left with 2 3, or else just like normal previous dot next is node and previous is node equal to node next. I mean, it's like pointer manipulation, that's it.
Yeah.
And at last just sudo dot next. So this is like crucial part is like I'm taking that value. If 1 and 1 are similar, I'll take the duplicate value in this and I'll increment by one node, and till the point I hit that my duplicate value is equal to how many nodes, I mean duplicate, just keep on going to the next. And the moment you find now I'm getting distinct one not equal to this, just make previous dot next to none.
Okay.
Yeah.
And where do you delete the node?
This only it will take care.
Okay.
Yeah.
Because
it's like
previous is already pointing to the node.
Exactly.
Oh, so you're using the dummy, right? Okay.
Dummy, yeah.
Therefore, it makes a very
easier little.
Yeah, easier implementation.
So in interview, we should start with a dummy only, right? I mean, it shouldn't.
Yeah, but this is a good solution, right? This implementation.
Yeah.
In fact, it will be the most optimized way of doing it.
Yeah.
If you look at the non-dummy node, sorry.
I'm saying that, can you explain how this line works? Previous dot next equals to none. I mean, how is it deleting?
So what it will do, so currently let's say you are at this, okay? So if your
Okay.
these two are equal, then I'll take this value. One value I'll take in the duplicate and I'll come to this here. Now what from here I'll keep on checking till which, if I find this is equal to my duplicate value, I'll move here. Is it equal to my duplicate value? Here it's equal to my duplicate. Then
Okay.
I'll make my node dot next till here, and previous pointer you're having to your dummy node here, right? To the dummies next I'll add none. So this dummy will get connected to 2. So this will be wiped off in between. Here dummy we have, before
Okay.
one we have none node, and that none will point directly to the this 2. So this will
Okay.
be gone. Yeah.
Okay. Okay. Oh, okay. I missed the initialization of previous on 9 9.
Yeah,
Got
that's
it.
it. It's like if you just draw the pointers, it's straightforward. Like you'll get it in a dry run.
Yeah.
Right.
So as Dilip said, without the dummy node, it will be a very complex code. That is
Exactly.
true. Maybe I can show you
Yeah,
mine
sure.
because I did it that way and it was a very huge code. It's not a well-written code though,
No, let's see.
but I will just
So
share
you
that.
didn't use dummy one, right?
Yeah, I didn't use
Okay, let's see.
because usually I was always trying to do it without the dummy. But when I saw the Naga's implementation, I thought, okay, that is the best way to do it.
In most of the linked list, I've seen people using dummy node everywhere.
Yeah, that is the best way to do. So but if you look at my code, it's so huge. Okay, I start from here. This is actually assigning the head to current first. My
Okay.
previous is null. And then I just do a while loop on current. And I'll just decrease my font size a bit. So then the first condition actually I look for is if it is current is next is
Available.
true. Yeah, and then I just compare the two pointers and two values of the next. So if it is there, then I do all the manipulations in this if statement, or else in this else I just assign the previous to the current and current next. I just move the current pointer, right? Because I've already assigned some value to the previous now. And then when I come inside here, actually I mark this node, this list node. What will be the deleting value? And so I go through this while loop and I try to identify if I can find any of the nodes to be deleted. Right? Okay, this is an extra node, I should remove it. And then I keep on deleting this, and then I come here. When I'm deleted, I look for, because now I have to delete my current node, which is the original node which has to be deleted. So if it is head, then I use it a different way, because I have to move the head to the next pointer of that current and then delete the current and then move the current to the head. So at least my head is at the proper position, or else actually the previous will be pointing to the next of the current. Yeah, and then I can delete the current and then move the current to its right position. So many, I think this will be eliminated if I use a dummy node, right? Yeah. And it will be a very straightforward implementation. Yeah, so
yeah, but this is also intuitive. Like I mean, it's same only that you took the value. Same thing I was also doing. Like you're matching which all values should be deleted.
Yeah, but specifically, explicitly, you have to do. And if you in an interview of a very short time, you might miss something, and then that might not be good for you, right?
So it will be n square only, right?
Why n square? It will be just O of n.
While inside while you have.
Yeah, that's fine. But I'm just moving on, even if I have while, because here I'm actually, moving the current pointer always, correct?
Okay.
So when you come out, you will actually be at that position where you left this while loop.
While loop. Yeah. Yeah, it's good.
Yeah, usually linked lists, they don't have that n square most of the time, right? Because you cannot come back and then go again.
Exactly. That's it.
Yeah.
I mean,
Yeah.
logic to remember also.
Right. Sometimes it's very confusing, but yeah.
Yeah, we can. Or somebody wants some other code like to share.
Santosh, you were talking about some Naga session. Is that the weekly session that Naga gave? Is this true?
Yeah, actually, he did it one of the, I think, Saturday afternoon, where he was
Okay.
talking about the linked list, most of it. Yeah, it was more of the linked list side, right? Yeah.
Oh,
Yeah.
okay. Yeah, I'll check that.
Yeah.
Okay, then let's switch to next.
Yeah.
Yeah. So max chunks to make the sorted array. Okay. So an array is given, which is a permutation. I mean, permutation of 0 to length -1. We need to split the array into some number of chunks and individually sort each of the chunk. After concatenating them, the result equals the sorted array. So what is the most number of chunks we could have made? Okay. So this is your array, and if you're splitting it into 2 or more chunks, will not return the required results. So they are splitting it into this and this, and after concatenating them, this is what they have obtained, which isn't sorted. So so only, I mean, entire chunk only you have to do. Like you can't cut it. That's why 1. And if you see here, this can be done, and further you can split it into this, which is the maximum number of chunks they are asking, most number. So here 4 you'll have, because after concatenating them, it will be in a sorted order. And array will have length from 1 to 10, and each element of the array will be permutation of elements of the array from 0 to length -1. So this is like index permutation only, right?
Yeah.
Okay.
But if you
Next.
see at the example too, in the explanation, what it says, you can split it into 2 chunks, 1, 0, and then other part will be 2, 3, 4. So that can also be a valid chunk, right? See, because if you have 1, 0, you can actually sort it. You
Okay.
can make it 0, 1, and 2, 3, 4, you don't sort it. And you just concatenate both of them. So it will be 0, 1, 2, 3, 4.
But maximum number they are saying, right?
Yeah. So they are saying it maximum because I think they are trying to match the implementation. I would say, yeah.
Exactly. Yeah,
Yeah.
definitely.
Yeah. Or else it's very difficult to come up with that solution.
Solution. Yeah.
Yeah.
That's why they have considered. Yeah. Otherwise, it would have been one slot. I mean, one cut will make it sorted, right?
Yeah. That is what my
0, 1,
thoughts.
and 2, 3. Yeah.
But to get to this, understand this problem was not so easy.
Exactly.
I don't know what about others, but first
I
of all,
got it now. This one, like it will be
Now I have
permutation
not
of
understood. I have not understood even now.
okay, so the crux of the whole thing is your array you have been given elements of the array which are from 0 to the length of the array, length -1 of that array.
one. Yeah.
Yeah. So if your array size is 5, so you will always have values 0, 1, 2, 3, 4. So if you understand that, then actually the problem makes more easier to actually visualize. Because what they are trying to do is they are trying to place each and every element at a particular index. So if it is not placed, so it means that if you take any element like in the second example, if you take element 1, and if you try to place it, because element 1 is at the 0th position, if you want to place it at its original index, which will be 1, so then you take both of those, because from 1 0th index to the first index, that will be the 2 places, and that becomes a 1 chunk, because that has to be sorted. So that is what they say about
It's
that.
like putting each element at its respective index, right?
Right, exactly. So
so it can't be done in one pass. Like I'll see whether this element array of I, array of I is present at ith index or not.
Yeah, so it can be done in one pass, only the way it says in the example 2, when it says it can be divided into 2 chunks, right? So then it becomes complex. You cannot do in one pass.
One pass.
To make it possible to do in one pass, therefore they are split, saying as in the second line of the example second in the explanation, where it says you split into the highest number of chunks possible.
Yeah.
So then it makes a one pass solution, because you take one, because one is not the right place, so you keep on looking where you can put one. So you take all of those elements which you are actually walking through that one, and then say, okay, those all of them form one chunk, and I will sort that separately. Okay. And therefore you keep on doing for the others, then naturally you will have to use the same logic for the other elements, or else it won't be a one pass solution. As all of them are the same index, so you consider each and every one as a separate chunk.
Separate chunk, yeah. So if all the elements are its at own place, then maximum number will be n minus 1, right?
Right.
Yeah.
If they are all, but if you look at the first example where none of them are at that position, right?
Worst case, yeah.
Right. So if you say in the 0th index you have a value as 4, so where should 4 lie? It will be at the last one, last position. So therefore the whole of it becomes one chunk.
Oh, because array indices is over after that, like.
Yeah.
Oh.
In the second example, what if I take the entire array as one and then sort it?
Well, but you.
Okay, go ahead.
Yeah. So if you take the whole array and then you sort it, but actually the sorting is not the way we are thinking about it. So their way of saying is, you have to pick up the elements in such a way that they can be sorted.
That will be one pass only. What he's saying, like, I mean, only one chunk. How will he get the maximum number of chunk in that case? If he'll take the entire array and sort it.
Yeah, that is there. I won't get the maximum.
Yeah. That is. It will be sorted, no doubt. But what their condition is, like, most number of chunks you have to obtain.
Yeah, that's a good thing to actually understand why they are saying it that way. But actually, their more focus is on making the chunks, making them as a separate unit so they can be individually sorted. And then you concatenate them. But if you make it one, usually, what they say, you can make it one only if all of the elements are not at the right position. So then it makes sense to actually sort all of them. But if you have some of the elements at the right positions, you have to separate them. You don't want to sort them. That is what
I think. Harshit's idea will work first one, right?
Yeah, first one it will surely work because none of them are at that positions.
Correct.
But in the second example, there are some elements which are at their own positions, so you don't have to actually sort them. Correct. So you make them separate chunks. And the ones which are not at the correct position, you take them out and make a separate chunk and sort them separately. Yeah, so maybe that is the way they are actually saying,
Basically, it is important to minimize the chunk size. That's what I understand.
Yeah.
Chunk size minimized so that maximum chunks you will have. Yeah.
But so weird problem. Yeah.
Like, do you want to share code, like?
I mean, I did not solve it, but looking at a second example, like, and after discussion, I feel like whenever while traversing the array, when you find a number which is less than or equal to, or less than or equal to the current index, like let's say if one is not at one is like at index 0, so that means like it has to be in a group. I mean, I can't increment a counter, let's assume. And if I go to the next index, which is 0, which is also not at current at 0th index, right? It's at first index. So it should be like in a same group. So when I go to the second, second index at which is at 2, 2 is at correct position. So that means I can increment a counter. Say that means like I created a one chunk at 2, right?
Yeah.
Yeah.
Looks good. Yeah.
When I go to the third, and third is, 3 is also at position where it has to be. So then I can increment a counter. That means like I can create a one more chunk at that point. So can I go with the assumption and?
Sandeep,
Yeah, that is exactly what it is. Yeah.
Okay.
Sandeep, could you please repeat? Sorry, I missed that.
So what I got from this discussion, and when I was looking at example 2 was whenever you find an element which is supposed to be at that particular index, because here the numbers are equal to the indexes, right? So if you are like 5 elements, the numbers will be like 0 to 4, right? So when you find an element which is at the right position, so that means it can be its own chunk. It can be in its own bucket, right? So that time I'll just increment a counter, because here we don't need to actually sort, but we just need to give a return the integer, the number of chunks. So I'm just incrementing the counter. Whenever I see if the number is if the at current position, if the number is at not its right position, is not placed at a right index, then I will not increment the counter.
But how would you count 1 0 as one chunk in that case?
I will not increment the counter. I'll just move my recursion, when I'm traversing, I'll just increment my recursion, right? Or
so basically, at 1 the counter is 0. At 0 also counter is 0.
Yes.
At 2 it will be 1. At 3 it will be 2. At 4 it will be 3. And you return just whatever counter you have plus 1. Is that what you're saying?
Yeah.
But actually, when you go for 1
whenever
and 0, that will be a 1 counter, right? Because your 1 actually is not at the right position, but it can be at the right position where it will be where the value is 0.
Can we say something like this? We'll have to, if we are examining an entry, we have already started our work. So we will say we'll have to count it as 1, but there is a trick to it. That let us keep a flag. The flag for that is whether the current thing is at its current valid position or not. If it is not at its valid position, then we don't increment the counter until we come across something which is at valid position. So at 1, we count 1, but our flag is not valid. Second one, because it is not valid, we don't increment the counter. 2, it is valid. We'll make it 1 more. 3, 1 more valid. Increment the counter. 4, 1 more valid. Increment the counter again. Next time, suppose after 4, suppose 6, 5, like that is there. If 6 comes, then we know that it is not its this thing, but this is the first time we are toggling from toggling our valid invalid flag. So we'll give 1 more entry, but then we'll stop it. How is that?
But why you are using flag? It's like whenever you hit the element is at correct position, just increase the value of chunk by 1.
But what if it is not in its correct position?
So then actually you find the maximum value and then actually put it there.
So what I'm saying is, for 1 0, suppose it was there is only 2 entries here. Suppose it was 2 1 0. Okay. Because of the flag, the whole thing will get only 1 increment from 0. Okay. And then only when something comes which is at its correct position, every time it increases. If we see that from the correct position to from valid assignment to invalid assignment is happening, the toggle is happening, we increment only 1 and keep it till it remains invalid, we don't increment anymore. So that way we kind of clubbing the whole interval.
Merging your kind of.
Yeah, there are possible ways of doing it,
How
but
will
there
that
are
work for 2 1 0?
So what is saying 210, you just go from start with 2 because 2 is maximum is 2 value, and then you go from 1, and at the 0 position you can place 2. So you take that as a 1.
Yeah.
So that would be
Yeah, so
one
basically,
chunk.
I think what Rajendra is saying, that we start a new chunk when we find an element at its right position. Is that right?
Yeah. That is what. The moment you hit the
But
right.
see, like in case of 2101 is at its correct position. So I don't know if that will work.
Oh yeah, you're right.
Sorry, which one?
No, he's reversing 102 as.
But what will happen in that case? You start with 2, and actually when you have something value 2, which is a greater value with the next value what you have, you keep on moving. So because that will be the value you will start with. So if you are 210, so the highest value right now is 2, because you come to 1, even though it is at the right position, but 2 is still greater than 1. So you don't do anything there.
Okay.
But then you go to 0, and at that time you say this is the right position, I can keep 2. So I can use the whole 210 as a single chunk. And therefore the count there will be only 1.
So it's
So
one
we are
part
saying
only.
like in case you witness a higher number, so until you reach that index, you should keep on considering that as a one chunk.
Yeah, that is what actually the implementation is, means. Yeah, I just ran it and it shows 1. Yeah, that is true. So because it's very confusing the way they are actually saying it, but and the implementation is very easy, but to understand how it is
Coming up, yeah.
Yeah. So, but what you say, that is a good test case. So 210 actually makes only one chunk.
Yeah, it is same as the first example, right? 43210.
Yeah, but 1 is at the correct position.
Yeah.
This is what all of us missed, I think.
And you have like, if it is 210 and 34, so then it will be 3 chunks.
210, yeah.
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 Basically, this approach is very similar to quicksort. This is what we do when we kind of try to partition the elements and so.
Oh yeah,
But
so because if we are partitioning and the ones which are at the same indexes. But what happens in partitioning, like if we have a test case 2, 1, 0, 3, 4 and 6, 5. So maybe a modified version of quicksort, yeah.
Yeah, we also kind of wait till, for example, if I'm partitioning and my pivot is 0, so we wait for an element lesser than 0 till we reach to that, and then we swap. So I think this is similar. Like we are waiting for the element to be at its correct position to start a new chunk.
Yeah, that's a good way to look at it. Yeah.
Modified.
And along
Yeah.
with what we have to take the track of the larger element.
Yeah.
Yeah.
I think there are a lot of ways to implement this.
So in that quicksort way, how will you keep on counting? Like suppose you have fixed a place for one of the element, then you will be going to left or right and try to pick another partition within the left range or right range. Because like it's gonna get confusing where you don't know, right? Your left or right is gonna be a chunk or not. Maybe you have incremented your counter by 1, getting one place correct.
Yeah. So in quicksort, we don't actually maintain any kind of count. So what I was saying,
Yeah, I mean,
the way
just to fit this problem to quicksort solution, I was just thinking, how it will kind of, if we were to implement it that way. I get your point.
Yeah. So maybe, in that case, you actually separate the whole problem solution in different buckets. Like if it is 2, 1, 0, 3, 4, 6, 5, you take only 2, 1, 0, 3, 4 as a sub problem and then do that, or maybe 2, 1, 0 as just a simple problem, sub problem. So I think that may be a modified version of quicksort to do it. Yeah.
Yeah, probably.
Yeah.
But
But a
again, if
similar
you
thoughts
add
on that.
chunks, will you make like that?
Yeah, it's like you're again making sub problem is you're making some chunks,
Yeah,
right? So
will a bit
it comes to that
intricate, I
again.
think. Yeah. But the
I
idea is
understand
similar
what
to
Jignesh
quicksort.
is
Yeah.
trying to say is how do I fit that problem implementation when I see a similar thing somewhere than how I actually try to use this implementation.
Exactly. Yeah.
But yeah, this problem actually gives you a good, something to think over, and maybe there are some tricks which we can use somewhere, which are very niche places. Yeah.
Exactly. Yeah. You want to share code like?
Oh, me?
Yeah.
Okay, I can share.
Yeah, sure.
I have the very normal one.
Yeah, it's okay.
So when I actually went through this code, actually, first of all, I didn't understand it earlier, but then I went looking for it and understand, and therefore I actually came with this implementation. So, oh, sorry, the explanation. So this is the array size of n. If it is this, these are the base things. I'm just keeping something like max of r, and max of r will be like whatever is the maximum value of an array value. Like in this case, if I have something like what we are talking about, 2, 1, 0 and 3, 4, right? So now in that case, my 2 will be the first value, right? So
Yeah.
array 1. So my max of r will be 2. Then I'll go to the next index, which will be the value will be 1. So I'm not going to actually increment this count over here because my max of r is not equal to that index value. But when I go to 0, at that time my index will be 2, and therefore the max so far will be equal to 2, and therefore I will increment that value over here. And then I go for 3 because 3 is at the right index, and the max of r will be 3 at that time, and also the index will be same, so I'll increment that value, and then I keep on doing and return this.
Yes.
Yeah. So if you look at the implementation, it's very simple, right, to look at it. Yeah, but to understand this, yeah,
that is bit like.
Yeah.
I mean, first time I saw C++ code like very small and lot more
I think
things.
you can implement the same thing everywhere, but they are using, some people are using stack values and some people are using the way Rajendra was saying, have separate flags and do that. But this was a very, so I first of all couldn't believe so it was such a easy solution, and to understand why it is so easy. Yeah.
So if the maximum element is at the 0th index, so in that case, the size, the answer would always be 1, right?
Maximum value. So, okay, what test case you want to take is?
I'm just saying that if the array size is 5,
okay,
and
I think
the
example
maximum
1.
element.
Example 1, right?
Example 1.
Okay, example 1 will be 1, 3, 2, 1, 0, right?
It
So
will be
what
one
will
only.
happen is your 4 is here, right? So your 4 will lie over here. So you will take the whole one as a single chunk.
Right. Yeah, this is what I'm saying. So if
Yeah.
array of length -1 is at the 0th index, then answer would always be 1.
Yeah. So maybe you have anything in between also. So even if the values are interchanged here, something like 2 and 3, still it should be 1, right? Yeah.
Right.
Yeah.
Yeah, makes sense.
Yeah.
Yeah, Shashank.
Yeah.
Solution.
Yeah. So I went through the solution only, like they were using stack. This is what I saw.
Yeah.
So
This is
So what
something
they're,
interesting.
yeah, it's like I'm going through the indexes along with the number in that array, and what they are taking in that range, they are calculating the minimum and maximum value they are appending inside a list. Like if I go from here, let's say, so at this index, what will have? Index will be your 4, and sorry, index will be 1, right? Sorry, 0. 0 and 4 you'll have. So this will contain 0, and this will contain 4. So one interval will be like 0 to 4. It will contain tuple of values. It's like
Oh, okay.
yeah.
So the minimum value will be 0. Okay.
Exactly. So one tuple will be 0, 4. So and yeah, so like this we have to do for the others. For others, what you'll have? Minimum will be 1 and maximum will be 3. That means index is 0, 0, 1, 2. Here 2, 2 will be there, right?
Yeah.
And then 0, 1, 2, 3. So minimum will be 1 and maximum will be 3.
So minimum will be reversed in this. Okay.
Yeah, exactly. And here again, 0 and 4. Then they are
Can you quickly
sorting
explain
it,
this
right?
stack?
Pardon?
Can you quickly explain this again? What you're doing
Sure,
right
sure.
now?
Yeah, let me have what somebody can explain. Like
Shashank, what
yeah,
did you do in the two last entries of 21, line number 21?
Yeah. I'm explaining. What I'm doing is I'll go to this index. At 0th index, I'm having 4, right?
Correct.
So
Right.
minimum of these two I'm taking. Minimum of I comma array of I. So minimum between I and array of I will be what? 0. So 0 I'm putting, and this is like maximum of 0 comma 4 I'm taking, which is your 4. This. So for every element,
Okay.
I'm keeping the minimum and maximum.
Okay. So what is the intuition behind this?
Intuition that I've just taken this code from there. I'm also going through. I'll let you know soon.
Okay.
Yeah. So now we are just sorting it. So if you sort it, it will be like 0, 4, and then 1, 2 will be there.
No, you'll have the duplicate 04 also, right?
Oh, sorry, I forgot.
Yeah, you'll have that duplicate 04, and then
So this will be like 0, 4.
Yeah. 2 times
1.
013, sorry.
Oh, sorry. 1, 3, 1, 3, right?
Yeah, 2 1 3 1 3.
So this.
You already have
yeah,
that 1 2, right? You make that 1 3, and the one which you have on the third one on line 20. Yeah, make that 1 3.
Oh, I did it.
And the last will be instead of 1 3, 2 2. Yeah.
2, 2. Yeah.
Okay.
So
now
now
you're
what
going
they are
to stack.
yeah, we're going for a stack, and it's like for every interval, like for every this tuple values, if your stack is not empty or interval of 0, so interval of 0 is the first value they are looking for. If your first value is now you go to the top of a stack, so first time it will not be executed, right? Because your stack is empty. You don't have anything on the top of the stack, so you don't need to do anything.
But are you not pushing that
in stack? Yeah, if not stack, that means
I think it's weird. Like if it's not stack and in the else, you try to pop.
No, actually, not stack means it is empty, right? So you
empty,
have to
we can
push inside.
Push inside.
Like the A equals to stack dot pop. That means like you are trying to pop even though it's not empty.
Yeah, it will be first time. It will be like this, I think.
I don't know. Some language might kind of error out.
No, it's correct.
Yeah.
So
Like
first,
that,
first time it's empty, so we are appending. Now we'll go for the next value 0,4. So they are checking. If not, this other condition they'll check, because this is false. So it will check if interval of 0, like this 0th index is greater than top of the stack and its first value. So if this 0 is greater than your 4, then again you append that interval to it. Right.
But 0 will not be greater than 4, right? Correct if I'm wrong.
Oh, sorry.
Yeah, so you'll have to pop this,
Pop it out,
whatever is in the stack. So your stack will be empty again. But you will append, what is that in the stack? You will append the next value, right?
A of 0 we have to append. A of 0, that means 0 I'll have to append.
Okay.
So it's a tuple of values I have to append. So when I popped out of it, so I got 0,4, right? So out of that, I have to append A of 0. A of 0 is 0. So 0 I'll append. Comma, what is that? Max of A of 1 and interval of 1. So A of 1 is 4 and interval of 1 is also 4. So 4 you will have to put again.
It'll be same,
yeah. So this is the second we have done. Now we are going to the third one, right? So again, if we go for the third one, your interval, this first value is greater than this. So that's true. No, top of the stack, it's false. We have to pop it again.
Yeah, you'll pop that again.
So it will be popped again, and again we have to insert
0 and
0 you will insert, and maximum of A of 1. A of 1 is 4 and interval of 1 is 3. So again 0,4 will be appended, right?
Yeah.
Now again we'll go for 1,3. If you go for 1,3,
yeah, it will be same 1, 0,
pop.
4.
It will be popped out.
Yeah. So you'll have the same value again there also, 0, 4.
Yeah, 0,4.
Yeah.
And at last, if you go 2, 2. So your 2 is greater than the top of 4, right?
No, 2 is not greater, right?
2, yeah, 2 is
so
not greater.
You'll again pop it.
Pop it out. Actually, this was not a good example. Yeah.
Yeah, so it is right. So because you will have only 0, 4 again in that stack, correct?
Yeah, remaining, yeah.
Yeah, and therefore the length of stack is 1, and therefore you will be returning value 1. Correct.
1, yeah.
That makes sense.
But it's again a very out of box intuition, right? Like,
well, it's very difficult to understand. Absolutely.
Yeah.
They're not very intuitive. It's very difficult to implement.
Yeah,
even after,
because why you are actually sorting it, the interval part creation is also very difficult.
Yeah,
so they have created intervals, and that also they are so weird intervals, like you are taking always the minimum and maximum at both sides, and they are going to be most of them similar values. But it works perfectly.
Yeah, that's true. So what we are doing is
we are actually trying to create intervals with the index and the values, right?
Okay.
And we always do it in such a way that we keep the minimum value for the start index and the maximum value for the end value. So whether it is the index or value, we don't differentiate, because our indexes are the values itself, right? They are the same. We have the same values and indexes also. So even if we actually interchange them, that's not a big deal. So therefore, they are trying to come up with those whatever those intervals, and then when you sort them, when you sort them, so you do all this the way this is stacks we are using, and try to find out whichever chunk actually on the top. Like, it is sort of monotonic stack.
Seems like
the monotonic stack will always try to look if some value is greater or smaller. So if it is not any value which is not suiting that condition, it will keep on popping out, and so whatever is left over in the stack will be your return value. Sort of monotonic, because I saw somewhere they are talking about monotonic stack. But it's a nice way to understand, instead of going through the very easy way that the one what I had
that was intuitive, but
no, not at all. But it doesn't make this actually starts slightly relates if you think more. because
Yeah.
you should actually do it the monotonic stack way, because if you look at the numbers also 4 3 2 1 0, if you use that in a monotonic stack, you'll come to know the values should be 1, because you'll
One.
pop each and every element out of the stack. There will be nothing left.
Yeah, at last.
Yeah, maybe you can say if there is nothing left, whatever the value, if it is 0, you add that to 1, because you will at least have one chunk, right? If the array is
Chunk.
not empty.
Not empty. Yeah.
Um,
Yeah.
Santosh, yeah, that was a very good explanation. Can we apply that to example 2?
Oh.
Yeah, sure. Let's try.
It might, like for 1 0 it might be, right? You know, because that will be a monotonic stack where say 1 0 will be one condition. For 2 actually the stack is empty.
Stack will not be empty. In monotonic, we remove 1 and put the incoming 1, right?
Oh yeah, we put the 2 then in that case.
No. I think we put 0. When we are at 0, we remove 1, we put 0 there, right?
Mm-hmm. Oh, okay. Yeah, then 2 is actually
nice.
greater.
Yeah. So looks like it is working, right? So for example, yeah, the approach works actually.
Can you explain like once?
Oh, okay. So, Santosh, you want to explain, please, because it is your idea.
Oh no, you're good.
Yeah.
Okay. So here it is. What Santosh was saying was basically we are maintaining a monotonic stack. I am starting with example 2.
Okay.
Because it is not any special case. It is general case. So
is a monotonic stack different from the normal stack? Because
Yeah, it's an implementation that we call it a monotonic stack, but using stack.
In normal stack, everything come and go, but in monotonic, either increasing or it should be decreasing. Monotonic means same, either increasing should go or yeah. That's a special case of general stack. Yeah.
So we are thinking about maintaining a monotonic increasing stack. So first stack is empty. So whatever comes goes there, which is stack is now having 1. Now 0 comes, but 0 is less than 1. So it cannot, if we put 0 on top of stack now, it can no more, it is basically violating the
monotonic rule.
Rule. That's why we remove 1 and put 0 there.
Okay.
Again, 2 comes, 2 is more than 1, more than 0, so it goes there. 3 comes, 3 is more than 2, it goes there. 4 comes, 4 is more than 3, so it also goes there. Now we have got 0, 2, 3, 4 in the stack.
Okay.
Now return whatever is size
Length
of stack, return that. That is 4.
Yeah.
Okay. In the example 1 is the special case. If you can go there. Oh, not even special case. Actually, that is also the same.
Yeah, so you can have 0 at the end, right? We can
so that will have 1.
So this is a decreasing stack, no? First one.
Yeah. So what we do is 4 comes, 4 sits there. 3 comes, 3 says, oh, 4, you have to go out. So 4 is removed, 3 sits there. 2 comes, it evicts 3 and sits there. 1 comes, 1 evicts 2, sits there. 0 comes, 0 evicts 1 and sits there. So at the end of the whole traversal, we have only one element in the array, which is 0. And the array of and the stack length is basically 1.
0, 1, 1.
Yeah.
Now it became clear, like monotonic stack. Totally, it is. Like what I was explaining was I myself was not getting. I was just doing the steps what code was saying.
Yeah, but the monotonic stack won't be actually valid for all. So what they were saying in some where I was looking at, you have to use two different ways of monotonic stack. One will be the increasing one and the decreasing one based on the condition. There is some condition we have to take care of because some test cases won't match for the monotonic stack, the increasing one.
Probably we can try. I think it will match because we are doing from left to right. And we are saying the expected order is always, so the valid assignment is the 0 should be at 0th index, 1 should be at first index, like that. So the problem is quite very fixed in that sense. It is very suitable for monotonic stack. We can try and see.
Yeah, okay. Yeah, what you're saying is right. I'm not saying, but it is like, there is some modified version of monotonic stack that we have to use. Okay, let's take an example when the values are 210, 3465. You know, so in this the value, the answer should be 4. 210, then you have 3, 4, 6, 5. Yeah, so the answer should be 4 in this case, but as per the monotonic stack, or 210, you know, you will have only 0 at the after 210. Then you will have 3 and you will have 4. So you will have 0, 3, 4. Till here it is okay. But when 6 comes in, right? So it is going to evict all of this, right? Or no?
Yeah. So first 2 will go,
Yeah.
then
No.
1 will evict 2, and 0 will evict 1. Now 0 is there in the stack, 3 is in the stack, 4 is in the stack, 6 is also in the
Oh
stack.
yeah, it will work. Yeah.
Yeah, but
What
when 5
Rajendra
comes,
says, it makes sense. Yeah.
so its answer should be 4 for this, right?
Yeah, it is 4.
Yeah, it's working. Like first 0 will sit, then 3 will sit, 4 will sit, 6 will sit. But when 5, 6, he finds that 6 is, so it will evict 6, right?
It will just pop out 6, but
6.
4 is smaller than 5, so 5 will be pushed into the
Sitting
stack. So
on stack,
0, 3, 4,
4,
and
5.
5 will be the
Answer.
The stack value, and then it will be 4.
Resulting.
Yeah, man, it works. Then the monotonic stack completely works.
Yeah, it's perfect then.
Yeah, but why they were saying that you have to use a modified version of monotonic stack in some case?
Some test case might be there which we are
Yeah.
not able to recall.
I think I have an intuition there. So maybe instead of popping only one time, like our examples, we might need to pop multiple times. I'm just trying that. Give me a little small, give me a
Okay,
moment.
no
I'm
problem.
trying that.
Let me see if I find some discussion, there is something, because when I looked at your stack solution, Shashank, I was also reading about that stack, and because it made more sense to go that route. But then actually I found an article somewhere in the same discussion forum, and I said, okay, they said you can use a monitoring stack. And then but then I lost in so much of those things.
So modified monotonic, they might be saying creating these intervals first.
Yeah, something like that. And therefore, this what you did, then now it made more sense to me when you have those two conditions on line 11, 12, a separate condition, and 14, 15, you are making it slightly different, right?
Yeah, exactly.
So that is actually the main, the what you say?
Change in monotonic.
Yeah,
Like
the important difference in implementing something like that. But I also try to look where actually I've read that. But I found stack implementation also very few.
But by explaining it, I mean, when you explained it like a monotonic stack, it looks like very easier to implement. But this implementation, like
that is on purpose. They are actually doing it on purpose, and monotonic stack has some drawbacks for some test cases. So we need to find a particular test case, and then I think we might be able to crack the whole thing.
Yeah, exactly.
But my question is, we saw in the given two examples, monotonic stack works, but how to develop that intuition?
I think like when you see that you have to work on previous values, you kind of think about stack. That's my way of looking at it. Like if you want to make a decision based on what will be the previous values, then you kind of try to figure out if you can fit stack. If you can't fit stack, then go for your next intuition.
Okay, yeah. Oh, that also sounds good.
Well, okay.
So in most of the problem it works, right? What you are saying.
So,
Yeah, sometimes like you have to do random choices too because you don't know what you're gonna, come forward or so.
Yeah.
okay. So I think I got one test case, Shashank. If
Yeah.
you go down in your what we said about 201, no, where
Okay.
you were writing, right? If you, yeah, if you just scroll down, yeah, here instead of 210, if you make it 201,
0, 1,
1,
and
yeah.
I've changed this also.
So yeah, yeah, no, yeah, keep that 5, 6.
Okay.
Okay, yeah, 6, 5, yeah.
Yeah. Mm-hmm.
So actually the output should be 4 in this case. But if you actually go the monotonic stack route, what will happen? You'll push 2 first. When you come to 0,
Okay.
you will evict 2 and then you push 0, right? So then you will push 1
Yeah.
and also you will push 3 because it is greater, right?
Okay.
So then you push
Hmm.
4. So now you have 4 of them.
Okay.
Then when you come to 6, you will
Pop out 4.
4, 3, 1, 0 all.
Because it's greater than all. It
Yeah,
will pop out. Entire empty stack will be empty.
empty. And then you'll
5
push
will be left.
6, and then you will actually, when you come to 5, you will actually push, evict 6. No,
Yeah. So 5 will be left in the stack.
but when you push 6, why you have to evict 5?
No, when you
I'm
put
not
6,
missing
next
something.
element is 5, right? And 5 is smaller than 6. So
No, we were actually evicting only the
smaller ones.
bigger ones, right? Or no?
Yeah, I think you made mistake.
Oh,
Only
sorry.
bigger one. Actually, I tried just now using monotonic stack, and 31 test cases passed, but I'm stuck at 201.
For this one, 201?
Only 201. Try 201. No, not the big one. Only 201. The monotonic stack. So what I did was, so very simply here is Sasan, could you please?
Sure.
I'm pasting it here. No, in the no. Let me give in the chat room. So this is what.
Let me take it from chat then.
Yeah.
Yeah.
So that is the stack at line 32, monotonic stack. Then for each entry of the array, we are basically saying if the stack is empty, then let it sit there. Otherwise, while if until there is anything greater in the stack, pop out, so that new one can go in. That is monotonic stack actually, right?
Yep.
And return the stack dot length. So basically, whatever is remaining in the stack. So our examples 1 and 2 are working fine with this. But when you try 201, then what is happening is it says there are 2 entries left, 0 and 1.
Well, it should be only 1, yeah.
Expected was 1.
Yeah, and I think therefore they are making that intervals sort of thing.
That's why they are keeping some extra data. In fact, they are doing monotonic only, looks to me.
Yeah, it is monotonic, a modified version or a advanced version of monotonic.
Yeah, probably the situation that we are going into, if we think a little bit, we'll also come with something which we'll understand rather than blindly following them.
Yep.
And it is already halfway through. 31 out of 52 test cases have passed.
Yeah, that's great actually. Yeah.
Yeah, it's nice.
It is so small. Yeah, it is just a simple monotonic one only, nothing else.
Yeah.
So 201, what will be the answer? Like first 2 will be posed, then 0 is smaller than 2. So 2 will be.
So what happens is 201, first 2 will be there. Then 0 comes because of line 36. 0 will evict 2. And sit there, line 37. And then 1 will come. 1 is fine with 0 at the first place. So it will also, 36 will not execute. 37 will push 1 into the stack. So the stack will have 2 entries.
Yeah. So answer is 2.
Answer becomes 2. but the expected answer is 1.
Yeah.
Yeah.
Then that this interval something it's doing magic over here. Yeah.
So I think monotonic stack, like you have the increasing monotonic stack and the decreasing monotonic stack. So you have
Okay.
to take help of both of them, but
Uh-huh.
only for taking the help of both of them, you will surely be using the same stack, but you will have to have a condition where you have to switch over from a decreasing monotonic stack to increasing monotonic stack. And that condition, if we get to
Come
know,
up.
then yeah.
Yeah, there is an inflection point from increasing to decreasing.
Yeah.
Then the unnecessary steps rather than doing these steps, we can eliminate them.
Yeah. Maybe
So something might be there. That's why they are creating this interval, right? Because of those problems only, they might be creating this interval.
Yeah.
I think up to the interval creation, it's fine. I guess it's confusing about this maximum and minimum thing. Like it makes sense that you need to consider index as well as the element. So they have intervals, and from there on, not too clear, what's the purpose.
Yeah.
Yeah, but there actually, if you look for the line, I think it is 9 to 18, it is a monotonic stack.
Yeah, this is a monotonic stack. Just
This
to
is a monotonic stack, right? Yeah.
work it in a better way, to avoid some of the cases, they are using this, what you say, creating the intervals.
Okay. Yeah, I'll try to work on this one the way actually Rajendra said. Let's see if I have a solution. I'll post it on the stack or Discord.
Yeah, sure.
Yeah.
Actually, just now I tried only for this 201.
It's not passing.
I tried flipping the basically instead of increasing monotonic to decreasing monotonic, it is not helping there.
Okay.
Because so increasing monotonic means think about this: whatever is greater, we pop it out and let the smaller things
get inside.
Yeah. So with increasing monotonic, we'll end up with 0 and 1 in the stack. With decreasing monotonic, we'll end up with 2, 0 in the stack.
Okay. Really?
So that is not helping.
2 zeros you said?
I mean, with decreasing monotonic, because 2 is greater, it stays there.
2 and 0. Okay. Okay.
So increasing, decreasing, both are not helping for 201.
So in decreasing, 2 will go inside and 0 will not go, right? And
increasing 0 will go, right? Because 0 is less than 2. Decreasing 0 will go.
Okay. Yeah. So yeah.
So what I would say, like when you actually push 2 first, and then when you get 0, you evict 2, the way we actually went for. But then when we get 1, actually we switch it to other, because now the stack has a content of 0. And then when we get 1, we go to the other way, maybe the decreasing monotonic stack, and then
add the length of
and then push 1. But there is something which we need to take care for this condition. It's not only just switching over based on looking at the top of the stack and the element what we have in hand, but there is some other condition we need to take care of for this switchover. Or else what will happen? It will remove all the elements in the stack. It will keep on switching between both of those conditions. So we'll always have a value 1. So yeah.
No, let's work it out for this. If we find something, I mean, if that condition is found, that it will make it everything. Most of the things will be done.
Yeah, maybe.
Okay, let's try.
Yeah. But thanks, Rajan. We got something very quickly.
Exactly.
Yeah.
Thanks, Rajan.
Right, guys. This is my first time attending, so thank you very much.
Yeah, thank you.
You're welcome. Yeah.
Welcome.
Great.
Okay, thank you guys.
Yeah, thank you,
you.
Tushar.
Thanks, Santosh. Thanks, Rajendra.
Bye.
Thanks.